My global is with a small lowercase z, and you don't need to know why, but the idea is data append is a debugging technique that I found valuable because I could go along in different handlers and keep appending the events in the order in which I encountered them. Because if you have two stacks like I have here, different handlers can be executing at different times, and you want to know which one happened first, second, third. And in networking, that becomes important. If you're sending 3 or 4 messages before the destination can even get back to you with the first acknowledgement, you need to know that. You might have to slow down the rate of your messaging. You may lose some packets because you did too many things too quickly. And that's part of what networking and the wonderful puzzle that you have to figure out is this too fast? Is it too much? And then you measure that and adjust your scripts. And one of them I showed you is the wait 200 milliseconds. And you'll find that that really works great most of the time. Now, the script local that's used by Mr. Tweedley is the one called L ports. And this holds on to the ports that we want to use, and we specified them right here, 1, 2, 3, 4 of them. And I could just put in another and call it 5, 6, 6, 8, 8. And when I restart the server, I'm using them. Now, the little mention here is thanks is clear now that UDP wouldn't be used where point-to-point login and session management is required. That's actually not the case, because when you use TCP on a web server, every time you make a connection, as far as the web server is concerned, that's a brand new connection. It doesn't remember the previous connection, but when you do session management, it ties them together, either using cookies or some other way of identifying. UDP can work exactly the same way. The concept, though, of TCP, which is what web servers use, mean you're establishing a connection so that data can go in both directions back to your browser, on your computer, behind your firewall, across the internet. That's how the browser knows how to get back to you. You've established a connection, then the data gets sent. And if the timeout is correct, you can receive all the data. Now, yes, we're trying that, and he mentioned here in the chat, so that stuff goes above the UDP or TCP level, correct. You have to manage sessions in either protocol because those are not persistent continuous connections that you get to use. The server keeps thinking this is a brand new connection, and you have to tie them together behind the scenes. And UDP would work the same way. The downside to UDP is you're limited to very small packets, such as 7K or 8K. And depending on the equipment and the operating system, you might get a 9K packet, but you may only get 6. And until you figure this out on your particular network installation, you're not going to know. And if you're going to get small packets and you don't care about a little bit longer transfer time, you go with TCP because there you establish a connection for 10 minutes or a half hour, and you get to keep using it. And now you get that. I can send a lot of data over this connection because you have built that connection. And UDP just doesn't have that rigidity. But you could never do a Vonage service or a Skype service using TCP because all of the handshaking and connecting takes too much time. You would have kind of a difficult time understanding who's talking on the other end. But hey, UDP, if you lose some packets, you can still hear the voice, you still understand what they say. So that's kind of some of the differences. You'll find that a lot of game servers for Halo and the others use UDP because they're just sending out a very fast stream of small packets to update the user's screen